Hello students, welcome to Eshwari channel. Students, in this video we are going to learn about preparation of alcohol. So the first method what we are going to learn is preparation of alcohol from alkene. So it is from alkene by hydration. So this is the first method we are going to learn. So here let us take simple alkene. Example CH2 double bond CH2. So we are taking ethene. We are treating with water in the presence of dilute acid like sulfuric acid. So students, in hydration what happens is one of the bond will break. Here you have double bond. So break one of the bond, and here you know water molecule is present. So water can be written in the form of H and OH. So add hydrogen to one carbon and add OH to another carbon. So what is the product you are getting here? So you will be getting CH3, CH3 single bond, CH2, and to this carbon OH is attached, OH. So you are getting alcohol. Now let us take one more example. CH3, CH double bond CH2. So students, this is propene. Propene we are treating with water in the presence of dilute sulfuric acid. So students, again here what happens is double bond will break and we are going to add hydrogen to one carbon and OH to another carbon. So to which carbon we have to add hydrogen, it depends on Markovnikov's rule. Markovnikov's rule. So Markovnikov's rule will be applied for unsymmetric alkene. So here this is unsymmetric alkene. Unsymmetric alkene, and this is example for symmetric alkene. Symmetric. So students, now what is the difference between symmetric alkene and unsymmetric alkene is, see for example C double bond C. So this is the carbon atom to which double bond is present. Between carbon double bond is present. So to this carbon I'll attach group A and A. So to this carbon also same group if it is attached. So here you have A and A. Here also same group should be present, A and A. So such alkene we call them as symmetric alkene. Symmetric alkene. For example, carbon double bond carbon. So to this carbon I'll attach A and B. So two different groups are attached. So to this carbon also I have to attach same groups, A and B. So this carbon atom has A and B. This carbon also has A and B. So then this is also symmetric alkene. Symmetric alkene. Another example, carbon double bond carbon. So to this carbon I'll attach group A and group B. And to this carbon I'll attach A and A. So what is happening here? Here groups are A and B, but here it is A and A. So this is different from here. So this alkene is called as unsymmetric alkene. So now you understood what is symmetric alkene and unsymmetric alkene. So here this is an example for unsymmetric alkene, because to this carbon methyl group is attached and hydrogen is attached, whereas to this carbon two hydrogens are attached. Therefore this is unsymmetric alkene. So now, according to Markovnikov's rule, what it says is hydrogen atom should be attached to the carbon containing more number of hydrogen atom. So see here, these are the two carbons we are going to consider. So this carbon has one hydrogen atom and this carbon has two hydrogen atoms. So which carbon has more number of hydrogen atom? This carbon. So to this carbon we have to attach hydrogen. So Markovnikov's rule says hydrogen should be added to the carbon containing more number of hydrogen atom. So hydrogen you will be adding to this carbon, and OH we are adding to this carbon. So what will be the product now? So it will be CH3 CHOH. So OH is added to this carbon. Single bond CH3. So 2 hydrogen plus 1, it becomes 3 hydrogen. So this is the alcohol which is formed according to Markovnikov's rule. So let us learn the mechanism for this. Mechanism. So mechanism for this reaction. So students, first what we are taking is, we are taking alcohol, that is CH2, double bond CH2, we are treating with water. So what is the product obtained here? So students, here no reaction will take place. There is no reaction here. Why? Because this is nucleophile. What is nucleophile? Electron rich species are called as nucleophile. See here, pi electrons are present. Therefore, this is electron rich species, nucleophile. And water, you know, 2 lone pair will be present. So 2 lone pair of electrons are present. So even water is a nucleophile. So you will write here nucleophile. So nucleophile will not react with one more nucleophile. Nucleophile will always react with electrophile. So therefore there is no reaction here. Therefore we are going to add dilute acid. We should add here dilute acid. Add dilute acid. So only then reaction will take place. So what happens is, water, when we are adding dilute acid, acid will be producing H plus ion. So this will combine and it will form H3O plus. So now this is electrophile. So this is electrophile. So now in the first step what happens is, take alkene CH2 double bond CH2 and then take electrophile CH3O plus. So this is the electrophile we are taking. So now what happens is, electrophile, write like this H, OH2 plus sign. So now this double bond which is present, so using this bond, this hydrogen will be taken by carbon. So it becomes CH3. CH3. So one hydrogen adds to this carbon, single bond CH2 positive sign over here. So what has happened is, one hydrogen is removed and it is attached to this carbon using this double bond. Therefore carbon gets positive sign plus H2O will be released. So if you remove one hydrogen, it becomes H2O. So this is the first step. Second step, take this carbocation CH3 CH2 plus carbocation plus take water H2O. So water will be having 2 lone pair of electron. Therefore this is nucleophile. So nucleophile will attack this carbocation. So second step, nucleophile attacks carbocation. You will be getting CH3 CH2 and this OH2 is attached. So let us write like this, O H H and then positive sign here, OH2. So this is the second step. Third step, same thing we will take here, CH3 CH2 O, hydrogen hydrogen, positive sign here, and then we will take again water which is nucleophile. Nucleophile. So lone pair of electron. So students, oxygen having positive sign. So oxygen is a electronegative atom. So if positive sign is present on a electronegative atom, it becomes highly unstable. So therefore what happens is oxygen will take this electron towards itself, and this will attack this hydrogen. So H will be taken by this lone pair of electron, and this electrons will shift here. So as a result, what you will be getting is CH3, CH2, CH2, then OH plus H2O takes this H and it becomes H3O plus. So it takes only the proton. H plus will be taken by this because this electrons are shifting to oxygen. So this is the mechanism for this reaction. So now let us study the second method of preparation of alcohol. So second method of preparation of alcohol. So this method is called as hydroboration. Hydroboration oxidation method. So we are going to prepare alcohol by hydroboration oxidation method. So here also we are going to take alkene CH3 CH double bond CH2. What we are going to do is we are going to take diborane B2H6 H2O2 hydrogen peroxide in the presence of basic medium. What happens is anti-Markovnikov's rule should be applied here. Anti-Markovnikov's rule. So what anti-Markovnikov's rule states is hydrogen should be added to the carbon containing less number of hydrogen. So this is opposite to Markovnikov's rule. Break this double bond, add hydrogen to the carbon containing less number of hydrogen. So out of this 2 carbon, which is having less hydrogen, this carbon. So add hydrogen here and add OH here. So here also we are breaking the double bond. We are adding hydrogen to one carbon, OH to another carbon. So only the difference is here anti-Markovnikov's rule should be applied. Hydrogen should be added to the carbon containing less number of hydrogen. So here the product will be CH3, CH2, CH2OH. So this is the alcohol formed. So now let us learn the mechanism for this. Mechanism. So it is a 2-step mechanism. In the first step, hydroboration takes place and second will be oxidation. So let us see the first step. So in the first step, what we are doing is take alkene CH3, CH double bond CH2, and then to this we are going to add borane, diborane. So students, diborane is B2H6. So now this is a actually a polymer. Take it in the form of BH3. So B2H6 can be written as BH3 and BH3 in the monomeric form. So now BH3, write in this form, hydrogen BH2. So total it becomes BH3. So now we are going to break the double bond. To one carbon we are going to add hydrogen. To another carbon we are going to add BH2. But to which carbon we should add hydrogen? So students, here what we have to remember is stability of carbocation. So already you know the stability of carbocation. Tertiary carbocation is more stable compared to secondary. So tertiary carbocation more stable than secondary, more stable than primary carbocation. So we should imagine a carbocation should be formed and that should be stable. So here if I write positive sign on this carbon, then it will be secondary carbocation. If I write positive sign here, it will be primary carbocation. So example see here. So same reactant I'll take CH3, CH double bond CH2. So now convert this to carbocation. So here CH3, CH positive sign on this carbon, and this is CH3. CH3, CH2, CH2 positive sign. So I can get two types of carbocation from here. Either positive sign on this second carbon or positive sign on this first carbon. So here this is secondary carbocation and this is primary carbocation. Secondary carbocation is more stable. So we have to imagine here more stable carbocation. So positive sign will be on this carbon. So imagine this is having a positive sign. So I'll write here partial positive sign and this will be having partial negative sign. So here boron will be having partial positive sign. Why? Boron is having only 6 electrons. So it is deficient of electron. So deficiency of electron means it will be having positive sign. And hydrogen will be having negative sign. So to the positive sign we are going to add negative sign atom, which is hydrogen. So hydrogen should be added to this carbon. Add hydrogen to this carbon and remaining BH2 add to this carbon. So BH2 you have to add to this carbon. So the product will be here CH3, CH2, single bond CH2, and then you are getting here BH2. BH2 attached to this carbon. So now again continue the same reaction. So this one I'll take here once again. First, so here we started with alkene. We'll take second alkene, CH3, CH, double bond CH2. So one more alkene we are taking and we are going to treat with this product. That is CH3, CH2, CH2, BH2. So this I'll write it as HBH. BH2 is written as HBH and remaining is this CH2, CH2, CH3. So now what happens is, again break the double bond. To this carbon add hydrogen, to another carbon remaining group you should add. So it will be CH3, CH2, single bond CH2, BH, CH2, CH2, CH3. So students, what is happening here? To boron you can see CH2, CH2, CH3 is attached. CH2, CH2, CH3 is attached. So we started with 3 hydrogen. 1, 2, 3. 3 hydrogen we started. So here you can see 2 hydrogen atoms are changed to CH2, CH3 group. And there is one more hydrogen. So again if you repeat the same step. So treat this with one more alkene. CH3, CH, double bond CH2. So when you are treating with one more alkene, this hydrogen will also be replaced with CH2, CH2, CH3. So it becomes boron. 3 groups are attached, 1, 2, and this also will be replaced by CH2, CH2, CH3. So it becomes CH2, CH2, CH3 3 times. So this is what you will get in the first step. So now we will go for the second step. So in the second step, hydrogen peroxide and basic medium what we have taken. So hydrogen peroxide is second step. Hydrogen peroxide is H2O2. H2O2 can be written as HOOH plus basic medium OH minus. So now this bond will shift to oxygen. It becomes HOO minus and this will be taken by this. So it becomes water. So now we will take the product what we got in the first step. In the first step what did we get? Boron attached to 3 times this group. So take here boron, CH2, CH2, CH3 is attached. CH2, CH2, CH3 is attached. CH2, CH2, CH3. So 3 times it is attached. So this one treat with this O minus OH. So now what happens is, again boron has only 6 electrons, 1, 2, 3, 4, 5, 6. So this is deficient of electron. So minus sign will attack this boron. So you will be getting, so this I'll replace with R. So instead of writing all the atom again and again, I'll take this as R. Even this one as R and this one as R group. So I'll write here in the simplest form as R, B, R, 3R, and then now this OOH is attached. OOH. And here B will get negative sign. Why? Because these electrons are donated to B. So now what happens is, OH is a good leaving group. So OH goes taking these electrons. So as a result, what you will get is R, B, R, and here oxygen will be getting a positive sign now. So oxygen getting a positive sign means you know that it is highly unstable. So as a result, what happens is, this R along with this electrons will be shifted to this. So you will be getting B, R, R, and this becomes OR. So R will get attached to oxygen, so it becomes OR. So see what we started is, we started with B, 3R groups. We treated with OOH minus sign. So product what we are getting is 1R. So 3R groups are there. 1R group is replaced by OR. Other 2 R's are there. So again continue the same procedure. So you are treating with HOO minus. So when you are treating with HOO minus, what happens is, even this R group will be converted to OR group, and even this R will be converted to OR group. So 2 times if you treat with this one, so here it becomes BOR, OR, and then OR. So R will become OR. So if we repeat the same steps. So last step will be treat with water. So when you are treating with water, what happens is, so this bond will break, hydrogen will be added here, and OH will be added to boron. This bond also will break. So to boron, OH group will attach, and to OR group, hydrogen. So this bond also will break, and here H will be added, and to the boron, OH group will be added. So what will be the product? Finally the product what we are getting is ROH, ROH, ROH. So 3 times ROH we are getting. So 3 times ROH, ROH, plus another product is BOH. So BOH 3 times we are getting. So this is the final product of the mechanism. So you know what is R. R is nothing but CH3, CH2, CH2 group is R. So if I write this once again, this is nothing but 3 times R is CH3, CH2, CH2, R, OH, OH. So this is the alcohol finally we are getting. So this is the mechanism for hydroboration oxidation method. So students, I hope it is clear. So in the next video, we will see other preparation method.